In this video lecture, I will explain binary to decimal conversion program in C. So first I will explain the procedure how to convert a binary number to decimal. Okay, so we know that a binary number will be in form of zeros and ones and base will be 2 and decimal number base will be 10 and it will be the numbers from 0 to 9. Okay, so binary number will be 0 and 1 and base will be 2 and decimal number it will be 0 to 9 and base will be 10. Okay, so the input will be the number, binary number, and the output should be a decimal number. So here suppose if I say this is the number 1 1 0 1. Okay, so 1101, this is binary number, and we know that equivalent of this is the decimal equivalent of binary is 13. Okay, so this is binary number and this is decimal number. So now how to convert a binary to decimal? If I say 1101 is a binary number and this is the, if this is the 0th position, then first and then second, and here it is third. So what we do, 1 into, and base is 2, so 1 into 2 to the power 0 plus next 0 into 2 to the power 1 plus next 1 into 2 to the power 2 plus 1 into 2 to the power 3. So when we calculate this, 2 to the power 0 will be 1, 2 to the power 1 will be 2. Okay, and here 2 to the power 1 will be 1 into 0, this will be 0, and 2 to the power 2 will be 4 and 2 to the power 3 will be 8, so it will be 13. So this is how we get decimal number from binary number. So now we'll see the detailed procedure here. So this is the condition we'll be checking until this n is nothing but the number which we have entered. So n is nothing but 1101, and until this is not equal to 0, we will be we will put this the condition in a while loop, and until the while loop will be executed until this n becomes 0, and then we'll be taking remainder and then n is equal to n by 10. So when we say remainder modulus operator, so remainder means it will give me the last digit of a number. Okay, and when we say division operation, it will skip the last digit of a number. So how we will see that? For example, if I say n is equal to 1101, so when I say 1101 mod 10, so that means what this modulus operator means, the remainder I am seeing. So 1101 modulus 10, so remainder I will get 1. So you can see here this 1 is the last digit of a number, and when I say 1101 divide by 10, so here I am seeing quotient. So when I divide it by 10, quotient I get 110. Okay, so here you can see this last digit we have skipped. So basically this remainder operation, this operation we are performing to take the last digit, and this operation we are performing to skip the last digit. Okay, and then this I is nothing but the loop variable, and then this is the actual operation, decimal binary to decimal conversion. So you can see here in this example I have explained. See, last digit 1, we need 1 is the last digit into 2 to the power 0. Okay, and then 0 into 2 to the power 1, and then 1 into 2 to the power 2, 1 into 2 to the power 3. So every time we need, see, first time we need 1 as a last digit, the next time I need 0, so that means I need to skip 1, and from 110 this will be the last digit, and the next time I need to skip this also, and then 11 will be the number, and then the last digit will be 1. So for that sake only we are writing these two things. Remainder I am taking to take the last digit, and this I am taking to skip the last digit. Okay, and then decimal plus is equal to remainder into power 2 comma I. So when I want to perform, suppose I want to calculate 2 to the power 2. So instead of writing this, we will be using a predefined function power, and we'll write 2 comma 2. So 2 comma I will be written here, power function 2 comma I, and this power function is a predefined function that is defined in math.h header file. Okay, so I cannot write 2 power I in program. I have to make use of this predefined library function power, which is defined in header file math.h. So what is this operation? We are saying decimal is equal to decimal plus remainder into 2 to the power I. Okay, this is the function, this is the actual operation we are performing. So decimal, because binary to decimal we want. Okay, so decimal we will initialize as 0 initially, and then remainder means it will give me the last digit. Okay, so for example, if 1101 is the number, okay, so last digit will be what? 1. Okay, so you can see here 1, 1 into 2 to the power I. So 2 to the power I, initially I will be 0. So 2 to the power 0. And then next time this will be the number. So remainder will be what? 110. Remainder will be 0. So next time 0 into 2 to the power 1, because I value will be incremented by 1. Okay. So here I'll take 1 1 0 1. So we'll check the condition. This is not equal to 0. Condition is true. We will take the remainder. So 1101 percentile 10. Remainder will be the last digit. So it will be 1. Okay, and then 1101 divided by 10, we'll get quotient. So we will skip the last digit. So last digit is 1. It will be skipped. So we'll get 110 as a quotient, and then I value is 0. This is the loop variable. So decimal is equal to decimal. This is same as decimal is equal to decimal plus remainder into power 2 comma I. Okay, so 0, remainder decimal is 0. Decimal will be initialized as 0, and then remainder is 1 into power 2 comma I value is also 0. So 2 power, so this is nothing but 0 plus 1 into 2 to the power 0. So this will be 1. So now this is decimal. Okay, so next iteration what will happen? My number will be 110. Now 110 is not equal to 0. Condition is true. We'll divide it by 10. We'll get the last digit 0. So remainder is 0, and quotient we will skip the last digit. So we'll get 1 1 as a quotient, and I value will be incremented by 1. It becomes 1 now, and in this equation we'll substitute the value. So here decimal is will be taken from the last step 1 into remainder from this 0. So this will be 1 plus remainder is 0 into 0 into 2 to the power 1. Okay, so this will be what? This will be 0. So this will be 1 only, and then this will be the number for the next iteration. So now 10 is not equal to, here there is a mistake, it should be 1 1. Okay, so 1 1 is not equal to 0. So 1 1 percentile 10, I'll get 1 as remainder, and quotient I'll get 1. I value will be incremented by 1. It becomes 2, and then decimal is 1 from the previous step, and then remainder is 1, and power 2 to the power I. So I value is 2 to the power 2. So it will be 1 plus 1 into 2 to the power 2. So it will be 5. And then next iteration, the number will be 1, and 1 is not equal to 0. Condition is true. Then 1 percentile 10, it will give me remainder as 1, and quotient will be 0, and I value will be incremented to 3, and then we'll substitute the value here. From the previous step, decimal is this, so 5 plus remainder is 1, so 1 into 2 to the power I is 3, so it will be 5 plus 8, 13. And then next iteration, this number will be 0, so 0 is not equal to 0, condition becomes false, we will come out of the loop. So this is the procedure, and the same thing is programmed here. You can see here the same logic is applied here. So we have taken one while loop, and until this n is not equal to 0, we are calculating remainder by by dividing n by n percentile 10. This will give me the remainder. Modulus operator is used, and then this will give me the last digit of the this will give me the last digit, and this will skip the last digit, and this operation is to calculate the decimal to binary to decimal conversion. With this operation, with the help of this operation, I'll be calculating the decimal equivalent, and then every time I have to increment the value of I, and in this n value is the initial this n is the this condition we are checking. Until this condition is true, this will be executed. So this is the body of the loop, and once the condition becomes false, when this n becomes 0, then we will come out of the loop and we will return this decimal value. Whatever decimal value we are calculating here, that will be returned. And you can see here I value is initialized as 0, and every time we are incrementing the value of I. And this program is made using function. So since we are using power function, so power function is a library function which is defined in mat.h header file. So we need to use mat.h, and this is the function prototype. And here in the main function, we are calling the function. So this is function call, and this is function definition. So same program, you can do it without using function. So in that case, inside the main, all these things you have to write inside the main only. But since we are doing it using function, so in function definition, there will be return type. So this is the decimal value return. So when we execute this code, what happens, the execution start from the main function, and then see we have taken data type of n as long. So when we take long, the format specifier will be percentile LLD. Okay, and enter a binary number, and this value scanf function we have written. So value will be taken from the input, value will be taken from the user. So 1101, suppose the previous example which we have took. So if user enters 1101, and then here we are see we have called the function convert n, so control will come to the function definition, and then this procedure will be this while loop will be executed. And once we exit from the while loop, the value of this decimal is returned, and again it will go to the main function and the value is printed. So this is the function prototype. So in my previous video lecture of function, user defined function, I have already explained the syntax of function prototype, function definition and function call, and I have already explained the return statement, function how the value will be returned from the function definition to main function. So the prototype prototype syntax will be data type. Here we will write the return type and then name of the function, and this is the argument, and we write semicolon. In function definition we don't write semicolon, and in function call we just write the name of the function and the argument we pass. So whatever n value we have passed here, whatever n value user has inputted, the same value will be copied to this n. Okay, so that's how binary to decimal conversion program will be done in C. Hope you have understood the concept. Thank you.